Hello everyone and welcome to Man Cave Coding with me, Craig Gilchrist. This is my first ever video tutorial, so go easy on me. I'm going to be a little bit rusty and I might stutter in places, and I'm a developer, so video editing isn't my forte, so it's going to be a little bit rusty, but bear with me please. This is the first of a three-part series where I'm going to be taking a look at the brand new Azure Kinect Developer Kit v2. This is an iteration on the previous Kinect. It's not meant for gaming. They're touting it as an AI sensor device when joined up with Azure, obviously, and with some built-in SDK capability as well. It's a vast improvement on the previous Kinect. It's got a 4K 12 megapixel RGB camera and a 1 megapixel depth sensor with passive infrared as well, and it's a pretty nifty device. I've got mine set up over here. You should be able to see now. So yeah, part one, we're going to be connecting to the camera, spitting out the IMU values and taking the camera images themselves and manipulating them. Part two, we'll be using the body tracking SDK to detect bodies, and we'll manipulate the image on those bodies. So we'll color the bodies in and pull some of the body count and some of the body information into a data grid. And then part three, we're going to combine some custom vision AI from Azure, and we're going to live stream the image to Azure, and we're going to detect brands. So I'm going to train up an artificial intelligent model using images of branded soft drinks, and we'll be able to hold up Coke or Pepsi or 7-Up or different brands up to the camera, and we'll be able to detect what that brand is in real time and tell you how far away from the camera it is. So yeah, that's the plan. That's what the three parts will be. But first, let's get cracking, starting to just connect to the camera. If I just jump back to this picture, what you can see is item number 3 here is the video camera, and that sits on the left hand side of the device on the front. The depth sensor sits slap bang in the middle of the camera. So what it does is, what the SDK does is give you transformation capabilities to allow you to combine the two images. So take input from the depth camera and provide that alongside a transformed version of the color camera, so you get a merged version of the two. So we're going to produce a camera image, a full color camera image, and we're going to grade things in distance from the camera with different colors. So let me just start up the application just to show you what we're going to build. So this is the application. So in the center is going to be the image source of the selected camera, and we're going to do this as a WPF application with a really simple MVVM structure. So we're going to have a single view model that handles everything, and we're going to do everything in the main windows.xaml. You can see here we'll have the combo box selection for the three colors, for the three cameras, sorry. We'll be able to jump in between. So this is what I was talking about, the grading. So everything less than a meter away, like my beer, we'll take pictures, the pixel value from the color camera, and then as we get further away, it will be graded different color. A transparent glass definitely wasn't the best value to thing to show you that. Take this moleskin instead, so you can see Up close you can see the colours, and as I move into the distance it goes red and then green, and then as it gets further away everything back here is blue. Okay, and the infrared sensor we're not going to do a lot with, we're just going to spit out the raw values, but that's the infrared sensor there. Okay, so that's what we're going to build, and these values here are the values from the IMU, so the accelerometer, the gyroscope and the temperature. Okay, so all of this source code is available on GitHub, and I'll post links to it if you're watching this on YouTube. And there'll be a video tutorial that accompanies this on my website, so both of the URLs there, but again I'll post them on as links in the YouTube video. Just as a quick couple of mentions, I think what I'm going to start every one of these videos with is a couple of shout outs on Twitter to just some inspirational people. Angie Jones I follow on Twitter. She's as it says there, director of the Test Automation University. She does lots of free courses. Most of them are Java, so if you're watching this, you're probably more interested in .NET. But she's just an inspirational character, and who really deals with some trash on Twitter, but she does it like a champ. So, yep, follow Angie Jones. She's Tech Girl 1908. And the other two I wanted a quick mention for are Brady Gaster, and James Clancy. So that's at JT Clancy and at Brady Gaster. Both of these guys, I put out a recent sort of quick video using the Kinect in Unity of a character doing some eye tracking, and both of these guys told me that I should be doing video tutorials, so it's because of them, which is either a good thing or a bad thing, but yeah, follow both of those guys on Twitter. Okay, so let's get started. What we're going to do, we're going to build this as a WPF app in .NET Core. So if you fire up Visual Studio, create a new WPF app. Call it whatever you want. I'm going to call it Kinect DK Demo 1. Okay. Right, since the application has started in the main window, XAML, we might as well go ahead and build that view. So if you think back to the layout of the application that we're going to build, it's essentially down the right hand side we have our combo box and our IMU output data as a data grid, and on the left we have the image output. So what I'll do is I'll create a 2x2 grid, and on the left hand column I'll make it so that the image view takes up 2 rows. So we'll do 2 column definitions. The left hand side, which just contains the image view, will fill up whatever remaining space there is, and the right hand side will have it to just fill up whatever space it needs. And our row definitions, the top one will just essentially be our combo box, so that one will do just the space it needs, and again we'll get the other one to fill up any remaining space. Okay, so that's our layout. We're going to create an image. And I'm not gonna. I'll do. I won't set any of the binding sources for anything just yet. I'll do those as I produce them, as I produce the view model properties. Right now I'll just create the controls. So what we'll do is put some nice spacing around a stack panel, because our combo box needs a label next to it really. So we'll put that into grid column 1 and grid row 0. I know I don't need to do grid row 0, but I like to be completely transparent. So again, a label and a combo box. Okay, let's do our stack panel orientation horizontal. Okay, and then for all of our IMU data, we're just going to pump it out into a data grid. So for now, I'll just pop one in. Row 1, column 1. Okay, so that is essentially our layout. We've got our image, which takes up the entire left-hand portion of the screen, a combo box for our camera source, and a data grid for our IMU data. Okay. So, as I mentioned, we'll be doing this, we'll be binding this to a view model. So let's create that view model now. And we'll call it the Kinect view model. I think it's as good a name as any. First thing we need, if it's going to have dependency properties, is we need to implement iNotify property changed. Go ahead and implement that. I'm just going to, this is how much of a noob I am. I forgot to increase my zoom level. Let's do that now. What I'll also do, so that we can concentrate on just what we need to, I'm going to pop everything into regions, and then I can collapse bits and pieces of code once we've discussed them. So this is our property changed event handler. And what I'm going to do as well is I'm going to create a separate class for each of those IMU values. So if I just run the application again so you can see it, each of these IMU values basically are going to sit inside an observable collection, and I want those values to come out, those values to be updated as we get new sensor information. So we'll create another view model class and call it, say, camera detail item. So again, another really simple class. It's going to implement iNotify property changed again, and this one I'm not going to put into regions because it is going to be very small. I'm going to have a name and a value. Ooh, not a string builder, I want string value. Because it's a dependency property, I'll have a backend variable, and the getter I will just be lazy with. the setter I will set the value and invoke our event handler. This okay, so this is our essentially for our IMU sensory output data that comes from the camera. Oh, very squeaky chair. Okay, so if we jump back to our Kinect view model again, let's start by setting up some of the variables, the dependency properties for that view. So I'll create a region called view model properties, and let's create some of those variables that we need. I'm going to collapse that event because we don't really need to see it. So the first thing we really need is the option values for the camera select. So for the combo box. So what I'm going to do is I'm going to create again another couple of. I'll create a simple enum. We'll call it output type, which represents the camera selection, the camera type selection, which is going to be color, depth, and infrared. And we'll create a class for those options as well. So let's do output option, and we'll have an observable collection again for the options and a single value for the selection. So we'll have name, and that'll be our key path, and we'll have output type. Okay, again, let's collapse these because we don't really need to see them. But what we do need to see is the dependency property for those for the view. So let's start with a output option for our selected camera type, and we'll call it selected output, and we'll create the dependency property for that. Okay, so that represents the combo box selection. Let's create an observable collection of the possible options. Okay, that's nice and simple. We'll need another observable collection for our IMU data. So let's do we'll call that camera details. Let's put a couple of comments on. So IMU output data and camera sensor output options, and on this one camera sensor output selection. Okay. That should be, actually, let's do one more. We also need a the image source for the current selection. So we have our image on the left hand side. That's going to be, should be representative of whatever camera sensor is selected in the combo box. So let's create a really simple property called current camera image, and we'll back it with let's call it image source. I'll just generate that variable, put it alongside it so we don't lose it. So what we're going to do, it is a dependency property, but we'll call the event handler. We'll call the property changed event on in code itself. So let's just call it current camera image source. That's probably a better name. Okay. Let's bind all of these now to our dependency properties. So this one was the one we've just created, so we'll say current camera image source. Our combo box, our selected value, selected value, is it selected item? It's going to be our I think it's selected output. Let's quickly jump back. Yep, selected output, and the outputs. I think I called it outputs. Yep. So that's our combo box, the image, and now it's just our data grid as well. So just remind myself what I called that. Camera details. So again, that's just going to be item source. And we also need the path for the display member for the combo box, which is name, because we just got name and value. Okay, so we've got our view model now, but it's not the data source for the view itself. So what I'm going to do, I'll start by creating a view model equals new Kinect view model, and I will set the data context for the view to be view model. I'm just going to let Visual Studio create one for me. Okay, if I run that now, there's not going to be a lot happening. But it works. Okay. Next thing we want to do is we're going to run our camera in a loop on a background thread, and we're going to update the view model properties back on the UI thread. In order to kick that off, we're going to rely on the loaded event, and to clean up, we're going to rely on the closed event. Okay. So what we'll do is we'll create two new methods in here in the view model called start cameras, and again I'll let Visual Studio create that method for me, and another one called stop cameras. Okay. So now it'll have put them somewhere completely random. Yep, in the middle of the view model properties. Let's create another region called camera control. Right. So we've got all of our dependency properties set up, and some of our views bound to those dependency properties, and our view model has been instantiated and is the data context for our view. So now what we need to do, what we'll do is we'll start with the IMU sensory data. We'll build that first so that the IMU's data has been spat out correctly, and then we'll go through each individual camera. But what we're going to do is we're going to run two background tasks, one for the IMU capture and one for the camera capture. Now, the IMU data can't be, one of the caveats of the Kinect V2 is that the IMU data can't be collected in isolation from the cameras, so the cameras need to be started first. So let's get rid of this. I'm going to create another region, call it member vars, and this will be just for holding all of our variables. And so the first thing we need to do with the start cameras is we need to check if we've got a Kinect developer kit connected to the machine at all. First thing I'm going to need to do that is get the NuGet package. Kinect, yeah. So we'll be using the Microsoft Azure Kinect Sensor SDK. In the second tutorial, we'll be using the body tracking SDK to track, to detect bodies and manipulate the image according to those bodies. And then finally, in the third tutorial, we're going to take a direct image output from the camera, and we're going to stream it to Azure, and we're going to do some real-time detection of brands. So I'm going to train a model in Azure Custom Vision with some Coke and Pepsi, and then we're going to spit that content out. We're going to train that model, and what we'll do is we'll live stream and maybe even download a mobile model for it and use TensorFlow as well. So let's start by just adding the Kinect sensor NuGet package. Okay, you see we get this warning message: the Azure Kinect only supports the x86, x64 platform. Any CPU is not supported, and that's obviously because this can run on Linux and almost any platform. So first thing we'll do is create a new platform. I'm only going to target x64, and I'm going to get rid of the any CPU platform target. Okay, that gets rid of our error message. The next thing we want to do is we want to start the cameras with the device configuration. Now, this has various options. We're going to be using the a 32-bit red, green, blue alpha color image format for our output, and we need to do so that we can, as I mentioned earlier, you've got the sensor itself with the camera that sits, the color camera that sits on the left, and the depth camera that sits in the middle. In order to get those two, the translation to work correctly, so that we can get a combined view of the two, we need to make sure that we're using 16:9 aspect ratio. Now, I'm running this on a pretty beefy machine, but I'll still just choose the 1920 by 1080 output. You choose whatever works. See what your FPS comes out like in the camera, but you can also set your desired frames per second, which I'm going to set to the maximum, which is 30. So now you've got essentially three sensors, but one of them is a combined sensor. The depth sensor is depth and passive IR. So when you set the depth mode, you're actually setting the value for both. So you can say completely off, just infrared, or near field of view, or wide field of view, and that will automatically start the passive infrared. So if you set any depth value at all, you'll also get the passive infrared value, the passive infrared camera turned on as well. Sorry, not camera, sensor. So we are going to choose the wide field of view. And one more value here. We're going to use synchronized images only. I had to do a bit of research into what this is, because there aren't many C# tutorials, which is why I'm doing this one. But all of the C tutorials say to set this value to true. So I did a bit of research into why. This actually represents two potential scenarios. When you've got multiple cameras connected together, when you choose synchronized images only, it will only return the frames where all of the cameras are synchronized, which is known as the external synchronization. It also has an internal synchronization where you'll only get the frames where it's managed to synchronize between the color camera and the depth camera. If you want to do any coding with this, I suggest you set this one to true. Okay, now using that configuration, we are going to start our camera and pass in the configuration. Now, if I was to run this now, you would see, if you were to run this now as it was, you would see the camera start and the LED indicator light up, but we're not doing a lot with it. That said, however, you'll notice that device is iDisposable. So what we want to do here is we want to stop the cameras. We also want to stop the sensors, which I've not yet started. I realize I'll show you in a minute. And we want to dispose of this object. Okay. So, as I mentioned, we haven't yet started the IMU. Let's also start the IMU. Now, what both of these methods do is just allow us to start querying the camera output and the IMU output. We are going to also need some of the device's calibration so that we can output the images later. So I'm going to grab those various bits of calibration now. And that's mostly so that we can do the transform. because we've got an aspect ratio that comes from the color camera and an aspect ratio that's coming from the depth camera. And in order to create a translation, we need both, but we also need the width and height of the color camera later, so that we can pass that into the transform, and so that we can stride through the pixels to decide which pixels to show. And that's not how you spell calibration. So I'm going to take it from the configuration earlier. So yeah, as I mentioned, we'll use this to create a transform. And create that as a property here. And I'm also going to keep a reference of the width of the color camera. Calibration, color camera calibration, width, resolution width. And I'm also going to do the same for height. Again, keep a couple of local fields for those. And as I mentioned earlier as well, we're also going to be jumping between the background threads, which will query the camera data, and the foreground threads, the UI thread, or the UI context, so that we can update the view models and therefore the view. So I'm going to create, I'm going to keep a copy of the current synchronization context, so that I can send messages to the UI, so that the background threads can properly update the foreground. Okay, so now we've got our UI context. I'm going to create two methods for capturing the camera data and capturing the IMU data. These are going to be the things that run on our background thread. So we'll do one called camera capture and one called IMU capture. And in our start cameras method, I'm going to just start two tasks. Okay, I'm going to do one more thing. I'm going to keep a reference of a local bool called application running. Now, inside both the camera capture and the IMU capture, I'm going to use a while loop that references application running. That should have been application running. Just so that it loops forever, and in the stop cameras, I will set application running to false. Now, what I'll also do there, because each of these loops will be capturing in real time, we don't want to, they'll throw exceptions out as when we call stop cameras if they're in the middle of that loop. So what we'll do when we stop the camera is we'll just do a task dot. We'll just wait for a second just to give those loops a chance to tidy themselves up. So we'll just wait for a second to allow that each of those loops to clean themselves up. Okay, so as I mentioned, we'll start with the IMU data. What I'm going to do is I am going to sort of set a default value for that camera details. And that reminds me as well, for the camera outputs, actually we'll come back to that in a minute. We basically need to constructor to set the 3 different options for our camera selection and set our defaults. We'll come back to that shortly after we've done the IMU data. Okay, so we're going to do a while loop in this, which is now running on a background thread. So we'll say while application running, do some work, and what we'll do is we'll wrap a try catch around everything, and we'll set application running to false if we run into an issue. And what? Go a little old school. We'll do message box.show. We'll just pop up an error message. I'm going to copy that structure for the camera capture because it's going to be exactly the same. Okay. So what I'm going to do first is get the Imu sample from the device. We've got an observable collection now of our camera detail item, which has just got a name and a value. What I don't want to do is, for every loop, keep filling it up with something with the same key and the same name each time. So I'm going to write a little method called add or update device data, and I'm going to pass in. We'll start with just the accelerometer timestamp data. Imu dot and so that it's not hideous and flickers so much, we'll trim it back to just hours, minutes and seconds. We don't want nanoseconds there. Again, I'm going to be a little bit lazy, and I'm going to let, oops, that's not what I wanted to do. I'm going to let I was going to let Visual Studio create this method for me, but it doesn't seem to want to play. Okay, I'm not gonna let Visual Studio do it for me. I'll create a private void add or update device data. Let's call the first parameter key, and the next parameter value. I know why it wouldn't play before. It's because I missed a brace. Okay, what we want to do is first check to see in our observable collection if there are any values that match that key. I don't really care about casing, so let's do that. So if we don't have one, we want to add it to the collection and set its value. We'll set its value in a second anyway, because right, this is one of the areas that we're going to need the UI context, because this will be updating the observable collection in a thread that doesn't own the observable collection. If we were to just add this now to the collection, it would throw an exception. So I'm going to do this on the UI thread. Yeah, I always forget about that. It needs a state parameter, which I'm passing null in. And what we don't need to do on the UI thread for this one, because we're not updating the dependency property and we're not changing ownership or attempting to change ownership, we can set the value just on our background thread. Okay, so if I were to run this now, we should get the timestamp from the accelerometer, and this is where it all goes horribly wrong. Let's test it. Oh no, there you go. So you can see this is, it's not much value in it in isolation, but it gives us the timestamp of the last IMU data for the accelerometer. Okay, let's add some more details from the accelerometer. Let's do X. Not really sure I need the colon. Let's get rid of them. Oh yeah, it's expecting a string, so let's do to string. Let's do Y and Z as well. Okay, you can see that wow, you know what, actually I'm going to round those off because that's quite a lot to take in. Give me a second. Let's do math.round. Let's round it to 1 decimal place. Again. Right, that's better. Okay, so you can see if I tilt the camera now, if I tilt it forward, which is quite difficult to do because it's on a big arm, but if I loosen this and tilt it forward, you can see on the x-axis, and if I tilt it sideways on the y-axis, changes there. And can't really swivel it around because it's on a big arm, but trust me when I say that the Z would change too. Okay, so we've got those values. Let's do the same for gyroscope. Actually, let's copy and paste the whole thing and just replace accelerometer with gyro. last one is temperature. I'll round that off as well. It should be just temperature it's on. Okay, and that should give us all of the IMU data that we need. So you can see temperature there. I'm in the north of England, so 13.4 degrees centigrade is pretty warm at the moment for me. But I'm out in the man cave, which is a part of the garage that a corner of the garage that my wife lovingly refers to as the man cave, which is why I've called the channel Man Cave Coding. Alright, so we've got all of our IMU data now. Now we need to start outputting the cameras. So let's jump to our camera capture. Actually, let's not. Let's first create a constructor. I'll put it in a region again because everything else is in there. And what we want to do is create our output options. I can't remember what I called it now. Outputs. Oops. New for each of our cameras. So we'll do color. Depth and IR. And okay, and we'll do our selected value, selected output as the first one. Okay, so if I run this again, we should have our combo box should now be populated and the value should be color. Yep. You know what? We've got some margin around this one, but not around this, which means it hugs the edge. It's a little bit ugly. I'm going to be a little bit anal here and change that. Give it a margin of 5 the same. Just run it again, see what it looks like. There you go. Much better. Right. So now we've got this this image on the left, which has a binding of the current camera image source, but that current camera image source isn't being set. What we're going to do now is we're going to loop through the in our background thread, our background task that we created in the view model, we're going to loop through, look at the selected camera source, and we're going to build an image source. We're going to build this current camera image source based on what's selected. So I'm going to start with the color one, the color camera, because that is one of the simpler ones. So we've got this loop now that for camera capture. What I'm going to do is you have to dispose of the capture object. So the device gives us a capture object, and you have to dispose of that once you've finished using it. So we're going to do this. Essentially sets it depends on how capable your machine is, but we're going to get one of these for every frame that your machine's capable of. And we're going to dispose of them once we're finished with them. And what we'll do is we'll do a switch statement on the selected output. Sorry, the enum. I'm going to start that again and let Visual Studio do it for me. Output type. There you go. And what I'm going to do is I'm going to create 3 methods again. I'm going to do one that says build color, build depth. Actually, let's give them a proper name. Build depth image source. And change that one to build color image source. And build IR image source. Okay. I'll get rid of the throws for each. And then regardless of which one is selected, we have managed to get a capture, so we'll assume that we'll have also managed to update our dependency property, which should update our image source in the view. I can't remember, it's called current camera image source. So we'll assume that each of these methods, build color image source, depth image source, and an IR image source, will each set a value for the current camera image source. Okay, so let's start with the color, because that one is really straightforward. Oh, not quite. What I want to do is pass the capture to each of these, because otherwise what was the point of capturing it? So the capture, really straightforward. We have to do it on the UI thread. So what we've got, let's do this as a delegate method this time, and it requires a state like I said before, but we're not doing anything with it. We are going to set our image source. Not that straightforward just yet. What we get from our capture is there are 3 values. There are color, depth, and IR. There's also a separate temperature, which comes from the depth camera randomly. So there's 2 temperatures. I'm not quite. I won't try to explain what they are because I don't know myself. I've not really looked at it. But what we get is an image, but it's not a system.drawing image. It's a system.azure.kinect.sensor.image. We need to convert that to an image source. In the color and the IR sensors, we're going to just do a straight up conversion of that. In the depth one, we have to rely on our translate to combine the color and the translation. The color and the infrared, the color and the depth image, and we rely on the translation to bring those images in line. But first, what I'm going to do is I'm going to create an extension method. So let's do that now. Add. I'm just going to create a static class called extensions. I'll call it public static class extensions. And what we're going to do is we're going to create a bitmap source from our Kinect sensor image, and we'll allow the user to pass in, we'll allow the developer to pass in a resolution. We'll just default to 300. So we have to do a little bit of translation here between some enum values and some we have to translate some of the enum values from image to system.drawing.image. To bitmap source in pixel formats, but we also have to do an unsafe memory stride and create that bitmap source from a pointer, which is we can get from the image object itself. And you got to remember that this NuGet package is essentially a wrapper around a C library, so which is why we have to do some of this low-level stuff. So this pixel format is a media format that we need for the bitmap source, but we need to create a new reference image from our image. That's right, isn't it? Yeah, so that duplicates it. We don't want to do any manipulation on the image itself, because the underlying capture might be doing something with it as well. So we create a copy of it. And we'll do a quick check. We only can work with BGR A32. Pixel formats. Okay, so that's taken our Azure sensor image format and converting it to system.media pixel format. So we can work with this one, and depth and IR. Everything else, we're just going to throw an exception. Guess that will never be hit, so we can get rid of the break. Now what we want to do is we have to wrap this in an unsafe because it is unsafe, and because we're not compiling with unsafe, I'm going to allow let Visual Studio fix that and allow unsafe compiling to the program. Pin. Oh, I am not. Okay. So now we've got a handle now to the raw, well, to a copy of the image given to us from the sensor. So what we want to do now is create a new bitmap source. Using this method, but we want to pull most of the data, most of the parameters from our reference. So the width in pixels, the height in pixels, the DPI, which is what we passed in our method as a parameter, DPI-X, DPI-Y, the pixel format, which we determined from our switch statement, the palette. I did try messing around with the palette, but I didn't fully understand it. So null seems to work fine. So our pointer converted to an int pointer. Now, the buffer size and stride, basically, when working with bitmaps in system.media and in system.drawing, what you have essentially is a buffer. And a buffer, if you imagine the bitmap itself as a grid, say it's a 300 DPI image and it's 100 by 100 pixels. You've got essentially 100 rows in 100 columns of pixels. The stride, the buffer represents every pixel in that grid. The stride represents each row. So it allows you to the buffer is the entire image, and the stride is how much of that image that you will be copying in each pixel, in each step. So the buffer size is, we have to do a bit of conversion here, is the reference, again from the reference.size, that should give us the buffer size in bytes. And then the stride we can get as well from the reference. There you go. And we should be able to return that as a source. Okay. So now whenever we've got a sensor image, whether it be from the infrared, from the depth, or the color, we can convert that now to a bitmap source. So I could, if we jump back over to the Kinect View model now, I could just go through each of these and return I can't remember what we called our variable now, image source. Capture dot color dot create bitmap source, and then we need to invoke our event, and this, I will remember what this is. Yeah, current camera image source, which should update our image every time. So I could do this for each of these. It's not quite what we want to do, but we can change each of these. So the infrared should be infrared, and the depth. So let's go ahead and have a look at that, see what it appears like, and if it works at all. There you go. Okay, so we've got our color output now. If I switch this over to depth, that is working. It's not wonderful, but I don't know if you can see my hand approaching there. And infrared, same thing. So essentially the color and the infrared are complete. Now what we want to do with the depth camera is we want to use our translation to translate the offset between the two lenses, and what I'm going to do is anything that's 1 meter or less from the camera, I'll use the color image pixel value. Anything that's greater than that, I will grade that pixel value. So I'll still take the color camera pixel value, but then we'll add a grade depending on how far away from the camera it is. So anything up to 1 meter will just be the color, and then we'll use red, green, and blue to shade that pixel, so that what you get are you get different levels of depth. Okay. So yeah, our color image source and our IR image source are essentially complete. The depth image source, we need an extra piece of data. So we've got our capture that we're disposing of. We're passing that into our build depth image source. Inside the build depth image source as well, what we want to do, we want 2 new using statements. We want one for an output image, which is going to be a color image. So the primary source of those is going to be from the color camera, and this is why we needed the color width and height right at the start. And the second thing we're going to need is our transformed depth. So what this does is it gives us the depth camera, but it gives us the depth camera values, but in an aspect ratio of the color camera and offset, so that it tries to match as best it can. It's not always perfect, and I'll show you that when we actually build it, but depth 16, and again we're going to use the color width and the color height. There's an extra parameter in here, which is the stride, because our depth is a 16 bits per pixel. We are going to do the color width multiplied by size of uint 16. Missing a brace. There you go. Okay. I'm going to wrap this around our image source, and that should give us a good start. Okay, so first thing that we want to do, we don't need to do this on the UI thread. We want to use our transformation that we got right at the start from our calibration, and we want to do depth image to color camera. And what that gives us, we can take the capture and our output image, our transformed depth image, and what that does is it will fill up the pixels of this image with the offset. Okay. Now I'm going to get rid of this To be honest, I'm going to get rid of all of the property changed events as well, because we don't really need them. It's done up top in the just after the switch statement here, so we don't need all of those either. Okay, so what we're going to do, we're going to get the transformed pixels, the color pixels, and then an output buffer. So what we're going to essentially have is 3 buffers, and we're going to be taking the color pixels. So our output buffer we're going to fill up with color pixel buffer values, and then we're going to do a couple of if statements to check on the depth from the transform depth buffer, and if it's greater than a meter, we'll start grading the color on those pixels. So first thing we want to do is get the depth buffer I don't know if you're picking this up on the camera, but one of my neighbours seems to be doing some sort of karaoke. Spent too much time in lockdown. But if I turned the gain up on the camera, you might be able to hear them. Either way, it's absolutely hideous. So the depth buffer gives us, for every pixel, it tells us how far from the camera that pixel is in millimeters. Then the other 2 buffers that we're going to need are directly from the capture itself, the color image. Get pixel BGRA. And another BGRA. This one is our output. So what we'll do, we'll stride through the color buffer. We'll check the corresponding depth for every pixel. If it's less than a meter, we'll just use the color. If it's greater than a meter, we'll start grading it depending on the depth. Output image, which we created earlier, as a holder. So we'll do okay. So the next thing to do is loop through the color. Okay. Okay, first thing we need to do is just copy the color buffer straight into our output buffer. And if I were now to create that from the output image, using our extension method, one thing you always have to do, which I should have done with the others, is freeze. Just more reliable memory management. But if I do that now and we select the depth image, it should look exactly like the color, because we're copying every single buffer. Now, just to prove that, if I now set the red value to somewhere in the middle, say 175. We'll see we get a slightly red tinted version when we choose depth. So if we choose depth, there you go, everything's got a red hue. So what we're going to do is we're going to rely on that depending on the depth. So we'll say if we'll get the depth first, obviously. So let's do var depth equals depth buffer I. And if the depth is greater than 1,000, because remember it's giving us this in millimeters, we'll set the red value of that pixel to full. Okay, let's give that a go. Now I'm going to use these crunchy cheese wheels. That should have worked. Helps if I actually select the depth camera. Let's expand that. There you go. It's everything greater than a meter away. If I use these cheese wheels, once it gets to a meter away, you'll see it slips into the red. There you go. And what I'll do then is I'll say everything between a meter and 1.2 meters will be red, and everything between 1.2 meters and 1.4 meters will be green, and everything beyond that will be blue. What we should get is 3 sort of very distinct distance lines. Just enjoy a sip of IPA while that works. There you go. So we've got 3 distinct distance lines. So we've got colour, because we've got colour because it's less than a meter. Then we've got red, green, and blue. You can see with my arm there. Now what I'm going to do one more thing here, and I'm going to show you. You can kind of already see that I've got this shadow around me, and there's a slight offset between. So I've got some shadow, and then there's some blue at the back of my head. Or if I place my hand up, you can see that there's a like a full color shadow around it, and that's because those pixel values are missing from the translation. So you can see if I push something up close as well, the sensor, in fact, let's make it really obvious first before we talk about this. So we'll say if the depth is equal to 0, what that means is there's no depth value for that particular pixel. So what we'll do, we'll set red, green and blue to 0. And that'll make it much more obvious. So now you can see everything that doesn't have a depth value is black. Now, if you remember that the camera is on the front left-hand side of the color camera is on the front left-hand side of the device, and the depth camera is right in the center. Now, if I place my finger over the color camera, you can see that I can still see parts of my finger because it's managing to get some depth value. But the offset is more pronounced the closer I get. And that's because the depth camera, my hand is now occluding the infrared, occluding the depth camera from being able to see my face. And that shows you the offset between the actual camera. If I switch over, if I hold my hand like this, there, and see that it completely occludes my face, but if I switch to the color camera, you can see that it actually doesn't. So that's not occluding my face there, and the depth camera it does. So you can see the offset between the two lenses. Now, if I put my finger right in the center of the device, you'll see that the whole thing would be occluded, even though if I switch over to the color camera and keep my finger in the same place, you can see where my finger actually is in relation to the lens. So my finger is over the depth camera, which means there is no depth data for most of the image apart from the little bit that it can see out the side. And that pretty much concludes the tutorial. We can mess around with these, and we can do hues of color. And I think in the source code I might actually change the color based on how far it is in a more minute value, where you won't get these lines. You'll get a more gradual depth from the camera. But essentially that's it for the first tutorial. What we've done, we've captured all of the IMU data, and we're capturing each of the cameras, the color on its own, the depth camera, and we're manipulating the color image based on the depth of objects from the camera sensor. That's really cool, actually. And we're also pulling the infrared camera out, which I'm not really doing anything with. And we're all set up. We've got this. What I'll do next in the next tutorial is I'll take body tracking data, and we'll expand this, and we'll use this data source to detect the number of bodies using the body tracking SDK, and we'll expand this data grid. We'll add an extra camera source that says body tracking, and what we'll do is we'll use the color camera and we'll color in all of the bodies that we see, and we'll include the body data in the in this data table as well, this data grid. So yeah, that pretty much concludes part one and my first ever video tutorial. So I hope it wasn't too amateur for you guys. Like I say, all of the code's available on GitHub, and there'll be an associated step-by-step tutorial as a blog post on my website. Look me up on Twitter, give me a shout if this helps you out, or if I've got anything wrong, again, give me a shout, or drop me a line in the comments. And yeah, I look forward to seeing you in part 2.